Yeah, good afternoon. I think it's working. Right. So let me end the music here. Although it's quite nice. All good things come to an end. Alright, so welcome again. Yesterday we the thumbnail of the video said that I was going to do repairs and assembling the new revision of the Pro 1 board, and I only did the last one. Actually didn't complete it during the stream, but I completed it after dinner. It was just one small thing I forgot, and it's working now, as you can see in the thumbnail of this video, or just by viewing this picture here. So the new APROM chip is just working fine. The only problem is that I have a solder option on the board, on the back of the board. I can show you, obviously. So the solder option here, which is to select if you're using a 128K or 512K SRAM chip. And currently there is a 128K chip on. So if you do not select that one of the two, the solder option, one of the inputs on the SRAM chip is not connected to anything, which is a select line or an address line, sorry, and it's uncertain which bank in the SRAM chip is used when you do not connect that address line to anything. So that was a problem. It's fixed now, and I already fixed it in the design of this board, so next time it won't be any problem. Let me check if there are chats already. I think a couple, but yeah, I'm working on Sunday. I work every day. I don't speak Chinese, I don't speak Spanish, but I do like watching the videos about that American guy who speaks perfect Chinese, Mandarin and some other dialects, which is totally awesome. He's got a huge YouTube channel, and many millions of people watch his videos because he looks like a simple American guy, and it's really funny that he always gets into conversations or just starts listening to Chinese people, what they say about him, and then react in Chinese as well, which is quite funny. Anyway, I don't speak Spanish. My daughter wants to take Spanish when she goes to high school next year. So I'll let her. She is still thinking if she wants to do a bilingual high school course, because she can choose if she only does it in Dutch or if she does it in English and Dutch. Maybe it's good to do the last one, but she needs some motivation if she wants to choose that. But anyway, we'll figure it out. We have 2 months left before we have to choose, so that's cool. Good afternoon, Mark, Ben, Owen, Nuno. Hey, Guy. Good afternoon. I still have something from you here. Yeah, it's on a stack of repairs, Nuno. And David, good afternoon. So, as you can see, there are some issue 6A boards on the work desk, and the customer needs one. So I got 3, and all of them got some 12 volt issues. So maybe some lower RAM that's not working properly. We'll figure it out. I'm going to work on that. And I've got plenty of more repairs, so let's get it going. Also, we'll do a live stream of assembling ZX HD interfaces, but I'm not sure if we can make it in this stream because I've plenty of repairs to do. I think I still have over 25 or 30 repairs remaining for people. So let's start with these issue 6A boards. If you have anything to ask, please let me know. I'm here for that. I try to follow the chat. It's sometimes kind of hard, but I'm going to put the chat on screen now. So I'm doubting which screen I should use. I will just let it stay there so I can follow it. I will zoom a bit in. Yeah, alright. So it's the letters are many pixels high, so I should not miss anything now. Alright. So, which of the 3 6A boards shall I use as a first? And we'll move this aside. If you want to see it working, I can do it. Just say that you would like that. I will zoom out the camera a bit because it's kind of in the way. Let me see if this works. I think this will work. It's good enough, I think. Okay. Yeah, alright. So, 12 volt problems, no picture, transistors, video, okay, I don't know. So, I have connected these boards before for a short test, and I think I didn't use the die card back then, but I'm going to do that now because it's a perfect check if the voltages are present and other stuff. These transistors really, or the capacitors really look old, so that could be a cause as well. 2 upper RAM chips have been replaced. I like to remove them before I start, but first let's do a quick power test. And I need some water. Well, Ben, obviously they get English at school, at high school, but a bilingual course means that that all classes will be in English and Dutch mixed, so they have to really think in English in the first year already. So I think it's a good thing, but I'm not sure if she's into that yet. She's doubting herself, but mainly because a good friend of her, a classmate, is going to do the bilingual course, and she might like to be in the same class. But we'll see about that. It's not the biggest, not the biggest reason, obviously, to decide which system you will use. But anyway, okay, let's get to the other side here and see if we can get any life into these boards. All right. I think now it's good to zoom out a bit. Oh, I still have a back pain because I did some squashing yesterday. It was too long ago since I did it last time, so I will do it next week because I need the exercise, I guess. Alright, so die card, which is really useful for first testing. Let me check, because the ROM sockets of these boards have, or ROM chips have been removed, but this one got a socket instead. If there are no shorts, nope. Okay, power is off. And I don't need video output, but it's just good to see what it does. Okay, I don't have minus 5 volts, I don't have plus 12 volts, and the whole system is hanging. But obviously that's because the ULA chip is not inserted. But first we have to get the voltages working. So minus 5 volt and plus 2 volts, 12 volts are not working, which is an issue with the tier 4 and 5. So let's get a schematic up of a 6A board and I will show you. Okay, 6A. Hope this will work. Nope, I just need to copy the microphone, just a second. And now it works, yes. Alright. So we have a 6A diagram here. It's barely noticeable because my head's over 6A, as you can see. Alright. Sorry for my throat. Should go away in a minute. Alright, so let's get to the power circuit, which is always a separate part of the diagram. So this is the circuit that creates 12 volts and minus 5 volts. And minus 5 is really a simple matter of using a Zener diode, 5 volt Zener diode. Not a big deal here, but plus 12 volts. If plus 12 volts and minus 5 volts are not working, so this says 5, but it should be minus 5 obviously, then it must be TR4 and obviously and almost always also TR5. So if I replace those two, there's a big chance that 12 volts is coming back and minus 5 volt as well. It's the same part of the circuit, which are all fed by TR4 here. But the problem is that if the cause of the fault is still present on the board, that we will blow it up again. So what we should do is do some measurements with starting with a resistance check on the 12 volt line and see if there's a very low resistance there. I'm going to do that right here, right in front of my schematic. So I can show you at this moment, but I'm just checking if the resistance on those voltage lines is too low. So I will put one in the minus in the ground. It's hard to show you because I'm right in front of the schematic on my screen. And I will measure 12 volts, which is on R62. Let me see if I can find it quickly. Or maybe C45, it's easier to find. C45 is one of the big ones here, and the plus side is 12 volts. And I got a resistance of nothing. That's odd. It is working, so why do I not have any resistance here? Let me check. C45. There's no resistance at all here. Oh, maybe I just not touching the... No, I'm not touching it correctly. Okay. We have a resistance of 2.7 kilo ohms, which I think is quite nice. Let me get a reference board, which is shoe free. It's another revision, but should get the same, about the same results. So measured from ground to 12 volt plus is about the same, 2.5, 2.6 kilo ohms. So that's okay. There's nothing wrong, seemingly, with the 12 volt line. I don't see any shorts on the 12 volt at this point. Measuring again. Yeah, this is just what I expect. Now the question is there anything wrong with the 5 volt maybe? And that's at the one side of the Zener diode, which is the 19, yes. So I'm going to measure from that side, and that gives me a resistance of 84 ohms, and that's quite low. 84 ohms. I would expect it to be higher. It sounds like a short, maybe in one of the memory chips. Let me check my reference board again, which gives me a 173 kilo ohms. So we have a fault on the minus 5 volt, and that's a good thing, because we are trying to find a cause for the problems on this board. And I think I can get to the work disk now and show you what I'm doing. I should get a Elgato Stream Desk, which I will soon, because I then can just push buttons instead of watching my screen which scene I should choose. So I have to use this one now. Oh no, this yeah, no. Yeah. Oh, of course I got my camera backwards. Okay, we'll put it back. Yeah. So. Okay. I'm not zooming in because it's a lot of work to still keep doing that. Right. So let me check again. The resistance on the minus 5 volt, which is this side of D19. Let me show you what the result is here. And sometimes the cables are not working correctly. So it's now alright. It's a cheap Chinese multimeter, but it works just fine. So you can see here that we got a really low resistance. And that could mean there's something wrong with the diode. You cannot tell from the outside, but I got some new ones in stock, so that won't be a problem. Otherwise, it could be one of the lower RAM chips. Those two are most to be suspected, so we'll try any of those. First, I will just no, I will do it nicely. I will solder out one of the lags of the diode to see if that's a cause of the problem. Because the diode is connected to ground as well, so maybe there is a short inside the diode, which is shorting almost completely to the ground. If that's it, then we just have to replace the diode. Otherwise, we have to get into the lower RAM chips. That's some more work, but we'll get them out one by one. In the past, I just disconnected or cut the with the cutter the pins where minus 5 volt is on, but it's not that nice because you're really destroying the chips before knowing which of them is not working correctly. So nowadays I just desolder the chips one by one and see if the resistance, the short is gone. That's what I do nowadays. So anyway, let's get this chip out. Oh, sorry, this Zener diode out at one side to start with. And we will check if the resistance is still here. I think it will still be here, but you never know. We could be lucky. And oh wow, it says 1.8 mega ohms now. That's quite different. So then I guess we have a short inside the diode. Maybe we are lucky. Let me check. And there it is. We have a 100 ohm short inside the Zener diode. So that's an easy fix, I guess, except for replacing tier 4 and 5. Let's get a new one. So it's the 5 volt Zener. Where do I have them? 541 volts here. Loads of them. I got loads of spare parts for ZX Spectrums, new ones, and if they're not made any more, original ones, which is really important if you do this kind of work, obviously. So let's see. And that's a cool thing about using the ZX die card and common sense and schematic. It really helps a lot with finding the cause of a defect. And sometimes I see a Facebook post about a ZX Spectrum that someone cannot repair or find the cause of the troubles. And then I think, well, it's really useful to have, for example, a ZX die card, or start with measuring the voltages at least. But the ZX die cards makes it visible, so you don't need a multimeter to know if the voltage levels are present or not. And of course, you don't know if the 5 volt is really 5 volt with the die card, but most of the time, if it's not showing one of the LEDs, it's just some of these parts in the power circuit. So, alright, that one is in. Let me measure again. Should be no low resistance anymore, but you never know. I think it should be gone. And we have a 1.5 mega ohm, so that's perfect. That's exactly the same with the reference board. Yeah, alright, so the problem is gone. And I do dare to test it again on the die card, but there's a really small chance that TR5 and 4 and 5 survived. I guess not, but let's give it a try anyway. Just a quick try. Nope. So we really need TR4 and 5. I could see instantly that the voltage was still not present. So let's swap those two transistors. And so this one was the bad one. And it's actually burned. I can see it now from the bottom. Oh wait, did the paint come off? Okay. So it's on one side you can see some reddish stuff. So I think it has burned quite a bit. Okay, let's get the transistors, power transistors, and let's get those old ones out. Right. So this is a 753, a replacement for TR5, and we also need a 653 as a replacement for TR4. I almost always check if the label on the transistor is correct, because you never know if I put back a part in the wrong cabinet. It could be, it happens. It has happened even with customers telling me that they got a wrong part in their bag for Harlequin kits and so. And I am careful, but the mistakes happen. You see it here on the stream quite often, so. Alright. Well, Mark, good question. What Sinclair themselves used for debugging, I guess. But the question is quite simple to answer, because back in the days in around 85, there was also someone in Holland which did ZX Spectrum repairs. He was called Albert Hoekman. I'm not sure if he still lives, but he was a genius when it comes to repairing ZX Spectrums. And he already had a interface made himself that showed up power lines and with LEDs and other stuff. So I guess he developed a die card himself back in the days. That was the only one that I know of. So I guess more people have done it. Maybe something like that has been published in one of the magazines in the past. I'm not sure, but he had one, and that was his way of quickly diagnosing a board and defects. But he also was able to repair quite other exotic stuff like Disciple disk interface. He was able to source GAL chips, for example, or sorry, PAL chips were in there back then, and they were quite expensive. They were 25 gulden each back in the days. So it was quite an expensive repair for an interface that cost something like £100 or so. But he was able to get the original PAL chips from Miles Gordon back in the days, for example. So he had his contacts. I think he was the most professional ZX Spectrum repairsman back in the days that I know of. I'm not sure who did repairs back in the days in the UK. Maybe Ian already, I don't know. But it was quite cool to see. So I guess Sinclair also had those kinds of tools, you know. I remember when Albert was fixing my Disciple disk interface back in the days, I bought him coffee in Houten in the HCC main office building. Anyway, so we replaced the two transistors. We'll clean it up with IPA later, just checking if I didn't make any mistakes. And I will do a quick measurement of the power lines when it comes to resistance once again, just to make sure there's nothing really wrong. That's perfect. That's perfect, and yeah, that all seems good. Alright, so let's give it another test. I should do something about this cable here. It's not really wanting me to turn it this way. Anyway, it works. So another quick test. I still don't have the ULA chip in, but for power it should. No 12 volt yet. Dang it. Okay, I don't want to keep it on too long, but there's still no 12 volts. Alright, do we have proper 5 volt? Well, it's hard to tell because it's showing 5 volt and I don't dare to power it on any longer because otherwise we get some magic smoke. So we still have a problem somewhere in the power circuit, I guess. There is no real problem on one of the voltage lines itself, but we still have a problem. What could it be? There are some parts that rely on 12 volt. I could give it a try with feeling if the chip gets hot, but most probably tier 4 and 5 will just fry out once again. Well, there are some other parts that we could check. So let's do a quick test on some other diodes here in the circuit, maybe some other capacitors as well. We have C46, which is also part of the power circuit, which is this one here. Let's see what the resistance on this one is. It's 11 mega ohms. Then we have D11 and D18, which I think are these two, or not? No, these are 17 and 15. D9. And I want to find D18 and the D11. So this is D18 and this is D11. So let me check if these are not showing up a low resistance. Also in the mega ohms, and we'll check if the diode function works, but it's hard to test it on circuit, but we can give it a try. This is reverse, so should check it the other way. Those are perfect. I think this is for the speaker, but I'm not sure. So also good. Alright. So maybe there's a problem with the toroid. That happens sometimes, especially if something has burned. There's a lot when a lot of power has gone through some of the parts. D15 is this one, I guess. Yeah, is a diode as well. Measures 0.5 voltage drop, voltage drop. Let me check. Shouldn't be high, low resistance, but nope. That's okay. What other parts are in that circuit? C80. I have had problems with those capacitors like this one here. Oh, it's on beep mode. That doesn't measure anything, of course. 36 kilo ohms. Same. This capacitor is 4 kilo ohms. No problem there. No problem here. No problem here. No problem there. All right, let me check C80. Where is that C80 gone? That's that one. Okay, I already measured that one, so that's no problem. Still, I suspect the capacitor, so maybe it's good to just replace them first. We'll know more then. We have a very low resistance resistor, which is R62, and this is 15. Yeah, that's this one here. Let me check. It's about 15 ohms, which is good. It's a 10% tolerance resistor, so that's no problem. So no cause found of the problems yet. I still suspect this toroid, so maybe we can just throw in another one and see if that's the cause of problems here. I have a couple of spare ones to work with. I don't know what else it could be at this point, because we have measured the -5 volts and plus 12 volt lines, and that was no problem at this moment. I don't want to fry transistors if I don't need to, so I just want to test it more safely. Is there anything else that I could check? Let me see. No, I think we're going to try the toroid. It's the part that I have here. Where did I leave them? All right. So these are used ones, but every single one that's in the cabinet like this has been tested. I will always write on OK or something like that, as you can see here. So let's do a quick check if that is a cause of issues. Good afternoon, Flashback Computing. And if this is not making any difference, then I will swap capacitors and replace them with new ones. it's it's loose, but I think it could be alright. It feels broken, but it doesn't seem so. Let's see if we can get it out. There's an added part in this board. I'm not sure if it's on the other boards as well. No, it's only on this one, below the toroid. So I don't know what that could be for, but let's see. Sometimes hard to get out, but could use some hot air maybe. Sometimes helps. I'm getting some movement now. Almost. Right. I'm quickly going to close one hole because it usually is not used by the toroid. And oh, I think a part fall down, and because there was something connected, and it's not connected anymore now. Which part fell down? I don't know. Oh, it's a pity. What was connected to the bottom of this toroid? I don't know. I don't know. I hate it. I think I heard something fall, but I can't see anything on the floor now. Strange. Anyway, let's put in a working one. Okay, I want to be kind of straight on the board because it looks better. Right. So let's do another test. And maybe I already want to replace the bifold regulator as well, but I don't know if this is the cause. So let's do a quick test again before doing anything else, because you want to know first what the cause of the problem is. All right. Hey, Jean-Claude, good afternoon. Okay, the quick test. Yeah, we got a lot of voltages. So it indeed was a matter of the toroid, replacing the toroid. So this one is dead, probably has a short, and you can see it's moving, but I don't think that's the reason of it failing. I guess the part on the -5 volt line has drawn such an amount of power that this one is fried inside, so we don't need it anymore. I should know, I should ask if it's good to save those old toroids and rewire them maybe. But I don't know. If anyone knows, then I will get it from the trash can. I will save it from that. But I don't know if it's worth the trouble. All right. Now we can go on with replacing the 5-volt regulator. I'm putting in a Recom DC-DC switching regulator instead of Traco power, because these are only €2.5 something, and the Traco powers are almost double the price. And then we can do some real tests. So we can put in a ULA chip, work in one. Alright, so far so good. So we fixed the power supply, seemingly. I still didn't put it powered it on quite long, because there could still be issues, of course, like capacitors. But from what I measured, there are no shorts to ground or low resistance to ground. So I think we're safe with putting in a ULA chip. It's clogged up. Let me try to empty the hole here. I got more, but this is the one I use the most. Alright. Oh, there's a lot on the top. Okay, that explains. Right. So a cool 5-volt regulator. Right. And the legs are not too long, so I think I can leave them, but mostly I shorten them a bit. Make sure there's no problem with getting the board into the case later on. Okay. I'm going to put on the ULA chip, and we'll do a quick test with video and see what happens. Composite video modification has been done already. There's no ROM on this board, but if we get a picture, then we know that the board is working, functioning. And we can do the rest later, like capacitors, boring stuff, you know. Alright. Okay, perfect. Looks totally fine now, which is good, thanks to the die card. There's no ROM in, of course, but it's just a counter nowadays, so you just have to wait until the counter is done and then we'll continue the tests. Great work by Dylan Smith and Brandon Elford, obviously, and Steve for the design of the board, and ByteDelight for manufacturing the kit. Right, let's see if the RAM is working completely. Low RAM is okay, otherwise we wouldn't get the perfect picture. And upper RAM seems fine as well. I will replace those two chips with original ones, because I don't like all the separate chips. For me it's ugly. The board seems yellow on the camera, but it's really green. Alright, so this board is done, it works. Okay, I'll replace this label here with, oh, garbage. Let me replace it with an OK label. Just a second, I will remove the garbage first. With some white spirit. Is it called white spirit, or is that, no, that's turpentine. I'm not sure what the name is in English for this stuff here. Wasbenzine is what we call it in Dutch. Okay, no more remains of the label, which I like. Something on the ULA chip, or it's tape. Sorry, not the ULA chip, the PCF 1306, which replaces the 6 logic chips, and also is used in a toast rack to select the upper RAM, the other RAM banks, I mean, together with the HEL or PAL chip, which is on the toast rack boards as well. Right, but this board is working, and we are going to reuse the ULA chip because I want to check the other boards as well. First one has been done. Okay. Nice. Let's get the relay chip off. And of course, the board is not done completely, but it works, and that's the defect has been removed. We can continue with our work. We'll get some protective material for my desk here. Alright, next one. Move some parts aside. I think I had one more. Oh, it's here. Okay. It gets messy when you need all the parts cabinets. So I really want to keep the desk clean before I start the next one. I always do that. Not always, but I like to do that. So I'm moving this aside. I will get my vacuum cleaner later. Oh yeah, you cannot see obviously what I'm doing here, but now you can. Okay. Hey, Uwe. I'm not sure if I pronounced your name correctly, but welcome. I'm not sure if I've seen you here before, but 3 amperes is way too much. I expect you to, if there's a defect or a fault on the board, that you can fry loads of parts before the 5-volt regulator will fry. But the original ones, just 1 ampere and it's good enough, including the replacement. Alright, so this board has replacement RAM chips. Yeah, that has been done manually by someone, not by me. And what is important to know is if these RAM chips actually use -5-volt and +12 volts. So I will check that first, but because maybe someone put on the wrong parts. There's also a pin of one of the RAM chips, capacitors underneath the RAM chips, which almost touches the ground plane, and that's scary. So I always like to remove that to make sure there's really no contact between the two parts. It's hard to see. I should just use my soldering iron, but now I can see it's there's no chance of getting any problems there. There's another one here. One here. Let me check again. It's just kind of bad design. Should be more space in between those parts with the full capacitors. Okay, no more chance of shorts here, so that's a good thing. And let me check the type of RAM chip that is used. RAM chips that is used here. So this is a HIB. I'm not sure which brand it was. 4116 P2DH. It's a Siemens RAM chip. It says here at least. Let me check if I can find a schematic for that. Oh, sorry, datasheet. I'm not entirely sure I can show my screen, obviously. So nice. Ah, okay. So you've watched. Nice. Ooh, okay. I do my best pronouncing names correctly, but sometimes it's hard. Okay, let me see. I got some. No, these are not from this part here. Siemens. Let me check. Is there a datasheet? Nope. Nope. There's a PDF here. Let me check. Datasheet. What is this? Are we getting viruses in now? No, there's nothing. Okay, maybe without the P2DH here. Yeah, perfect. So we got one here. I will save it for later use. You never know. Okay, so what power lines does it use? It uses minus 5 volts, it says here, plus 5 volts and plus 12 volts. So it should be completely compatible, which is good to know. Then we can leave them in for now. I could test them separately, obviously, but for now this is good. I haven't tested this board because there's nothing on here. It does have a composite video modification, I guess. It seems so, but let me check. Yep. Okay. So it's a matter of testing. Nothing strange to see here. Or except for a ROM chip, which is also pulled out. There are no shorts on the bottom. And nothing on top, so we can give it a test and see what happens. Right. Okay, no minus 5 volt and no plus 12 volts. So tier 4 and 5 again, most probably. But let's check the resistance on the parts once again to know if there are any obvious causes for this. White gas, okay, white gas. Is it really English, guys? White gas, is that the word for the cleaning stuff I use? The British people can reply to that, or someone else maybe. Alright. Okay, let's check the minus 5 volt diode again. This one gives me a 52 kilo ohm, which is no problem. I think it should be higher. Let me get my reference board. We can use the other one that has been repaired. I think it could be higher, so let's make sure it is actually working or not. I will replace it otherwise. No, it's okay. This is for 44K, so that's perfect. So that part doesn't seem to be dead. Let me check the 12 volt lines here. The resistance on the 12 volt is 2.2 kilo ohm and rising, so that's cool. Yeah, the other one as well. Okay, so until now I only suspect these two parts, maybe the toroid, but I'm not certain about that yet. Okay, 20 kilo ohms, 1 mega ohm, 0.6 mega ohm. That's a bit low, but still very high, obviously. What did give? This gives me 14. So what could be causing the lower resistance on this part here? C80. Oh no, no. This is too low. It's rising now. 200 kilo ohms. Let me check again. I got it in reverse just a second ago. No, this is 14 mega ohms. I'm doubting something about the capacitor or something else in the circuit, so let me check. C80. D17 is not connected to it, but it's kind of parallel, including C49, but that's just a very small capacitor. But let me check the diodes here. Oh, I wanted to measure it this way. 40 kilo ohms. The same. Mega. Mega ohms. All right. Which one did I forget to measure? This one here. Also mega ohms, so that's not a problem. Let me check the 15 ohm resistor. Yeah, it's working. Another one here. Okay, so until now I still suspect only those two, but the resistance on C80 was lower. It could be that the tier 4 is causing that. So let me just replace those two transistors again and see if the resistance over C80 is rising. It seems like tier 4 has been soldered out, but I can't tell if it has been replaced. But anyway, yeah, white spirit is terpentin, but white gas is then most probably was benzene. Oh, if the core is broken, then it will not work anymore. Okay. Ah, yeah, of course. Okay, so most probably the toroid was indeed defective because it was broken. That's a good reason. Good explanation. I guess someone has been trying to repair this board, because I think he must have tried to replace lower RAM chips and then still didn't make it working, so that's my best guess. But now it's in my hands to breathe new life into it, and we will succeed in that. Right. There was a solid blob on the board. It's scary. Alright. Oh. Right, so far so good. So what I said is I want to check the resistance once again. Okay. It's still in the kilo ohms, so it's still lower than I would suspect, but I'm not completely certain what the cause of that could be. Maybe also that toroid, but I'm not sure. Let me do a quick test off camera just to see if power lines are back. Yeah, they are back, so that's good. Maybe you can, we cannot see something because there's no ULA chip, but let me show you. So the power lines seem to be back. I'm still careful. Plug in the ULA chip now. Let's see if there's an output. Yeah, we do get output, but we do have a problem. So something is not working properly. I think the CPU is broken. Yeah, this board is dead. So let's get the CPU out. We did get colors and all, so I don't think there's any problem with the power circuit anymore. But we're going to work on the CPU. I could have checked for clocks. I didn't, so maybe I should. But I'm lazy. I can still do it. We have to wait until the desoldering station warms up anyway. So let me do a check on pin 6, I think, for the Z80 clock. Pin 6 of the Z80, yeah, pin 6. Okay. It should give about 3.5 megahertz, obviously. We should be able to dream that number. So I'm only going to measure that clock signal on pin 6. Frequency, it's on hertz. Now it's on hertz. 1, 2, 3, 4, 5, 6. Let's see what it says. Nothing. Okay, maybe there is another problem with the clock then. Let me see the power circuit. So we'll power down the... What am I smelling? Something burnt? No, I think the soldering iron only. You smell something when you're not sure about what the machine is doing, then it's scary. Don't mind the multimeter, it's just showing garbage. Right, let me get to the screen. Yeah, alright. So, clock. The clock is derived from the ULA chip, but so we have pin 32, which actually carries the clock and is buffered using a transistor. So maybe the transistor is dead. That could be the cause. So we can just measure pin 32. Otherwise, there's something wrong with the oscillating circuit for the clocks. Let me check. Yeah, so here we have the 14 megahertz, which is used for that, but we cannot. We obviously we could see if there's anything wrong with the clock, but it's really uncommon that a crystal dies. So I suspect the transistor. I don't suspect the 1K transistor, resistor, but we can check that. But I suspect the transistor here, and there's a small pull-up to 5 volts, but I don't think that's a problem. So let me check if there is a clock on pin 32 first. Let me get back to that side. Maybe I should put it standing because you can see better what the clock signal is. Pin 32. It's hard to reach because there's a heatsink on top here, but we should be able to do that. Okay. So we have 40 pins. 39, 8, 7, 6, 5, 4, 3, 2. This is pin 32. Nothing. Which is odd. I have no idea. Let me check for the reference board. I should get the ULA chip off. Just want to make sure if I'm measuring this correctly. So first we have pin 6 on the Z80. Can I power it on by this hand maybe? Yeah, we got 3.1 megahertz. Yeah, 3.4. Okay, that's good. I don't know why I'm not getting any picture. Again, this is wrong output, so this is perfectly fine. And just to make sure, I want to see if we get a clock signal from pin 32 as well. 9765432. Can I reach that without messing this board up? This gives me a nothing. That's odd. Not sure why this happens. Pin 32 I said, did I? Pin 32, yeah. Why am I not measuring anything on pin 32 then? Not sure. Let's try it again. Bad connector. Should replace that. Right. $40. 9876543 2. I guess it's because the signal is too low. We could take the output of the transistor, but I think it's not worth trouble because I cannot measure on pin 32 of the ULA chip. I thought I could, but I should check it later on. But for now, I want to know if the transistor is dead. So let's just replace it and see what happens. So we are talking about TR3, which is, I think, this one here. No, this is 8, 7, 8. It can be 2 8s. 6. Which one was it? I'm not sure. I can't find it. I don't see a clear label. Maybe on one of the other boards. I think it's this one here. I will make sure by measuring what it's connected to. So one goes to pin 6 of the Z80. It's clear that it's the left transistor here. Let's get it out. Right, so this is a ZX 313. I got some here. I need to test these, as you can see, but I got some working ones, which has a small symbol on it that I tested this. Right, let's get back to testing it again and see what happens. If we get activity on the die card, we know it's alive, but it's not. Let me check the Z80 again. Maybe there's just a problem with the Z80, obviously, but there's still no 3.5 megahertz on the... Oh, there's no ULA chip. That's my bad. Sorry guys. Anyone noticed? This won't work at all if we put down the ULA chip, because the ULA chip passes through the clock when it's not the ULA chip is not doing anything else. Let me check again. Yeah, look at that. We got activity and it stopped. It stopped. Did I fry? No, we got a 3.5 megahertz. So we got a good signal now. The only problem is that the Z80 is completely non-functioning. It does something, but I guess that also killed the transistor maybe then. So that's my best guess. We will replace the Z80. Are you still liking this, guys? Let me know if you enjoy watching ZX Spectrum boards come alive after maybe a decade or more, I don't know. Alright, so as always, I start with reflowing all the contacts with fresh leaded solder. I have one window open, so I got some ventilation in my room here, which is important. Not because of the lead, but because of the fumes of the flux inside the solder wire. Not healthy. So, right. Now for some tough tools and cables, which are on the way. Hey, Renee. Needs more smoke? No, I don't like smoke. Oh. Okay. Anyway, do you have a power regulator on your reference board? Yeah, I got just replace it with a Recom DC-DC converter. It's not really that hot yet, so. This just takes some time. We'll get there. Sometimes it goes faster when I do it by hand, not with the solder station, because it really needs some minutes to heat up properly. Though it says it already heated up, but it's not that good sometimes. Hey Nigel, good afternoon, and thank you David. I like that as well. I want to buy a better one than this one. When somebody knows a better brand, I will source one. This one takes too long. And I think it's a bit loose, so let me give it a twist. Yeah, it's loose. That's one reason. It's not clogged, so that's no problem. So during the next weeks I will continue with all the repairs. This is just still start. There's loads of other things to do. Takes so much time. I want one that gets hotter a little faster than this one. It's working better now. You can see it really needs to heat up. The element it shows up. It's got its reached the temperature, but it really didn't completely. So. Hey Robert, good afternoon. You really do not have to press that to the board that much, but sometimes not all the holes are open, so I need to do a couple once again because of the old solder that's on. I think after these something like 8 we should be able to lift it out. Four more, then we can give it a try. Let's start wiggling. That looks quite nice. So let's see. Will it behave? And let loose of this board, or does it still want to be on there for all eternity? I think we win. Right. Let me take a close inspection. If I didn't damage anything, it looks perfect. So let's put in a socket. Not all the holes are that clean, so I think I need to touch them for a second with some solder wick. Alright. Just a quick check again if I didn't create any solder bridges. I think it's good. Yeah, it goes in quite nicely. And let me grab a 28 pin socket as well for the ROM. Now we're doing this anyway. Some drag soldering. This part I like. It's really therapeutic, don't you think? Right. Nice. 28. Where is my 28? Use a crowbar. Nope. You do that. Now we need to be gentle for these really awesome ladies, old ladies, these black ladies, black with red. They need our tender touch. They need our patience. And I won't go any further with that thought. I will stop here. Right. But like any human, sometimes you need to go to the dentist. Sometimes you have a bad tooth and it needs to get out. And if you want, you can get the hole replaced by something new. And this is the same what we're doing here. Almost. Or just fill out the hole. Alright, it smells badly. I'm going to open another window. I could test the CPU, but my experience tells me that this board just needs a new one. So we're going to test it with this new CPU. And see what happens. Right, that works, but we have a low RAM failure, and D6 I guess, yeah it's D6. It's not getting hot, but it's probably D6, 5 and 6. So two bad lower RAM chips. I'm not completely certain if the chips are really dead. It could be the quality of the soldering of the sockets, and I'm not sure about that. What we could do, of course, is it's very easy. So this is 6, this is 7. Let's put in the one on D0 in there, and D1, and then we know for certain that if the parts are not working or if it's a socket. Nope, it's a socket. I hate that. So probably this previous guy has done some damage on the board. Oh, it could be a problem. Let me check once again. But I bet there's still a problem with D6 and D5, which means we have to get the socket off the board and see if there's any damage on the board. And yeah, it's still the same. So, oh my god, this board, you can see sometimes it takes a lot of time, especially if someone works on it that hasn't checked his solder work before. Okay, well. D5 and D6 was that. So the chips are okay, I think. The sockets look brand new, but the solder work doesn't. And there's nothing to see in an obvious way, so I guess we just have to get the two sockets out, which will be kinda hard. Because they're in between other parts, you know. Let's do that. I guess there's some damage on the top side of the board. It happens to me as well. If you have a bad manufacturer, these are all by PCP. This is a good manufacturer, so this board is a quite good quality one. But there's another one that has a very fragile tracks on the board. And this is going to be a lot of work because of the bad soldering quality. So always check if there's any damage, especially on the top of the board, before you solder in sockets. Use a magnifying glass or something else. It's been starting to clog up a bit, so we will remove that. It's better. Need more heat. What percentage? And you said, oh, 5 or 6. Yeah, 5 or 6, yeah. But it's D5 and D6. So the D7 is the upper RAM, the most left RAM chip. So 5 and 6 are the ones right next to those, next to that one. I could also do some measurements on the tracks, because all tracks except two ones are connected to each other. but it's better to just see what happened below these sockets. These sockets come off in a harder way than this Z80 CPU, believe it or not. So I don't know what solder the guy used that tried to repair this board. Maybe he didn't clean the old solder from the board first, I don't know. He did put in sockets, so. There's a slight chance that has to do with the ULA, the socket. The ULA chip is working, so maybe the socket, or maybe some other parts on the board that may pull down or pull high the data lines, but I don't think so, because if that would be the case, then the die card won't boot up at all. You get loads of other errors. I think there are 3 still filled up with old solder, so we're almost there. This should work. Let's get these 2 sockets from the board, off the board, and see what's underneath there. More wiggling. There's 1 pin still stuck, so we'll use some more heat for that, and then it will get detached. Nothing to see there yet, but we'll inspect in a second. Right, let's see. Can I see something that has been damaged? Actually, I can't, so I wonder what it could be then. Nothing to see here. I will measure if there's continuity between the tracks and the ULA chip. But I don't see any damage, which is a pity, because I really thought I would see something. So let's get back to the schematic. Alright, so the first thing is measuring all but those 2 specific lines that go to the ULA chip, which should be connected to each other. So of course all the voltage lines. For example, pin 1 is, let me check, it's a voltage line going to -5 volt. That should be connected to all the other chips, so here as well. Yeah, it's no problem. Pin 2 is a specific data line, we'll measure that later. Pin 3 is a write signal. No problem there. Pin 4 is also a control signal. Pin 5 is a 2. Okay, pin 6 is a 6. Pin 7 is not used. No, it's used. Let me check. It's a 0. Pin 8 is I think 5 volts. No, 12 volts. Yep. Pin 9 is 5 volts. Pin 10 is a 5. Pin 11 a 1. Yep. Pin 12 is a 4. 13 is a 3. Pin 14 is, I think, the other data signal. Yeah. Pin 15 is another control signal, and pin 16 is 0 ground. Right. Now let's check if the two signals going to the ULA chip are connected properly. So from pin 2, pin 2 is connected to pin 14. That's no problem at all. It's with all the chips, but from IC 12, pin 2 goes to, let me check, D6, obviously. This is the chip for D6, and that's connected to pin 30 of the ULA chip. 9, 8, 7, 6, 5, 4, 3, 1, 0. Doesn't do anything. That could be a cause, obviously. Let me check for the, oh, this is D7, okay. So I'm at for pin 31, so this is pin 30. It's not connected. So we seem to have a problem with the connection between the data line signal from the RAM chip to going to the ULA chip for IC 12, and the same for IC 11, which should go to D5, which is at pin 29. That is connected. Okay. That's odd. Oh, it's corrosion on the ULA pin. Ah, damn it. Sorry. Okay, it is connected. It's just the side of the ULA pin is not making proper contact. Okay. There doesn't seem to be a problem. Okay, so what is causing this problem then? I don't know. Of course, we have some resistors. Maybe one of those is messing things up. And I see a cause of an issue. Let me show you the schematic, and I will explain what I'm thinking that could be the cause. Hey, Jirai. Did you receive the pack yet, Jirai? I hope so. So I just measured the wire, the track on the board, going from IC 11 here to pin 29 of the ULA chip, and from IC 12 to pin 30 of the ULA chip, and those connections are working. It's just that the pins of the ULA chip were a bit dirty on sides, corroded, no big deal. But what you can see here is that there are 470 ohms resistors going to the other side of the board, if you can call it that. So they're all connected to the upper RAM chips. And in between there is a resistor. So the good thing is that the edge connector, which is on this, what is it? Let me check. Yeah, here. So this is the edge, part of the edge connector, and you can overrule the data on the edge connector because of these resistors. And these resistors are not present in the +2A and +3, but they are present on all other models, like the Toast Rack and +2, the Gray +2. And the good thing is that if you have an interface that, for example, overrules data when the keyboard is read, you can the ULA chip will actually read that data instead of what the Z80 is the machine itself is sending. So the separation with those resistors is good for that. But the problem is, if there's a defect in one of the upper RAM chips, it could actually mess up the what's arriving at the ULA through the resistors. So my guess is that the 21 and the IC21 and IC20 are not working properly. So we will get two dose out. Yeah, that could be another cause, but I did measure. I think I did measure if there's a short between those two signals. Let me check it again, but I think there wasn't. No, there's no short between those. I think there are two upper RAM chips failing, so we probably didn't need to get out those two lower RAM chips or the sockets from them. But let me check which two chips are probably messing this up. So I said 20 and 21, which is this one here and this one. So we will get those two out and we'll test again. I think that will solve our problem. And in the meantime, we could put back these two lower RAM chips. Yeah, why not? The sockets in at least new ones, obviously. Well, as I said, there have been some board manufacturers that used fragile material. So there's at least one manufacturer that has had pads and tracks that come off very easily. Maybe thinner material, maybe worse glue between the copper and the board itself. But anyway, when that does happen, you can repair it. But most important is to use very tiny wire, which is shielded. For example, special wire that's used in transformers and other stuff, or just very tiny insulated wires. For example, I use wires that come from 80 pin IDE cables from back in the days. I have plenty of those, and these are so tiny that they go. They're perfectly for this use. I wonder if I should test again first. Let's just do it to make sure there's no other cause that we have just removed. No. So I say it's those two upper RAM chips. I'm almost certain, but you never know. I wonder if I could have known in another way that those two RAM chips are dead. I wonder. Maybe by detaching the resistors in between first. That could have solved it. I still can do it. Now I'm here. So maybe in the future I could just lift one of the legs of the two resistors in between those data lines that separate the data buses. These come off quite easily, so this won't take too much time. So that's one way of making life easier. Just detaching the upper data bus, or at least the suspected data lines. That could have saved some time. you still can't see what I'm doing obviously, so let me get back to the other cam here. So with each board I'm still learning. I hope one day I can dream from just touching the board what the cause of the fault is. I can sense it. But for now we're at this point, and you can always improve your knowledge and your skills by doing a lot of these boards. Couple more. I think at least a couple of you have a desolder station like this one. I think Renee does, maybe Jirai as well. I'm not sure Mark has one. Yeah, that's a good one. Bare wire can be used as well, but it's indeed harder. And I'll always put a piece of the wire inside the pad, the full pad, so it will stay on a lot more easily than just putting it on top. And I also use a tiny drop of super glue to fixate the wire to the board. Ah, you have a better desolder station than I have then, I guess. Although I don't trust Weller anymore nowadays. But maybe I should get a better one. You need to wait until the pads have heated up as long as I have, Renee. I wonder. Because if it can save me time, then I'm interested. Doesn't feel that nice, but they will come out. Oh, I'm lifting tracks. Oh no, oh no. We're just talking about it, you know. At least 2 tracks are lifted now. I don't like that at all, but what can you do about it? So we need some wires in a second. I did my best to avoid this. Oh, I see loads of tracks being lifted at the moment, so I don't like this at all, but anyway, let's get it going. I think at least 3, 4 maybe. 4 tracks are damaged. Yeah, maybe 5 even. So for some reason this side of the board, although it seemed more easily, seems to be damaged easier as well. So it's a pity, but we'll get it sorted in a second. It's hanging by the track of the board. It's really ugly. I don't like this. Which one is it? Oh, it's that one here. Okay, we'll fix it in a moment. Oh, it's ugly. Blech. We'll get it fixed. I've done it before. really odd that it happened to this side of the board only. Hasn't happened to me before. But as I said, could be the glue between the copper and the board. Oh my god. I'm not sure if you can see it, but it's really terrible. So, let's get some wire. Nice. So, as I said, what I use is this extremely tiny wires. And the camera's not focusing well, so you cannot see it, but these are really tiny and I like them a lot. It's the best I have. And from one IDE cable, 80 track IDE cable, 80 wire, you can make loads of fixing tracks, fixing wires. So what I will do is close a window first. It's getting windy. Alright. Oh man. Okay, I will use some super glue to fixate the tracks first and then see what damage I need to repair after that. I don't think it's too bad, but I didn't suspect it, so that's why I don't like it. It's one. Now I really should use should need a microscope to show you what I'm doing, but I guess you can imagine most of it. Okay, this one is only connected at the upside. Let me see what is the best thing to do with this one. I think just put in a tiny bit of wire so I can solder it from the other side. Just a second, guys. Now there's super glue on my finger. All right. Okay, some more glue on that pin. Then there's one big track up there, which is totally pulled out. So we're still only finding out if this was the cause of the troubles with the lower RAM errors that we got. And we will find out. It's just taking a bit more time. So we don't need to put back the chips at this moment. I just want to fix the tracks and see if we can get the board working again with only 16K of RAM. Oh man, this track is so bad. Nope, this one won't get put back in the hole there, so we just will cut it. Yeah, and we'll put some new wires in then. You're right. So as I said, I use wire from inside. It's a hardcore wire from inside, 80-pin IDE cables from the back in the days. I got plenty of those still left. I need to bend it once again, and then it will get into the socket. Where's my cutter? So this is also an operation. Right. And then continue it to the other side of the track. Okay, I got 2 more tracks I think that I need to fix, and then we can do a quick test of the board and see if the problem has gone. Vanished. Okay. Track on the board is moving as well, which is really hard because it's touching other tracks now, so it's really not an easy job. The good thing is I get good eyes, so you don't need anything else to do these kinds of fixes. I'm not confident that's good enough, so we'll check that later, but there are a couple of more really bad tracks. Oh, come on, get away. This is really terrible. But of course you want to know if we will get this board up and running again, and I bet we will. Okay. Almost done. I hate it when the tracks move. It's so bad. So this board isn't the best quality, but I will get it fixed. Alright, let me check the chat. 87. Who is who needed a ban? Did you remove someone's chat? Okay, so Hecko FR301. Okay, I will check that out. Right. Okay. I hope it will stop moving now. I think it has stopped moving the one wire. That's what I waited. That's why I waited a bit for the super glue to cure. Okay. Right. Yeah, that will work. It's only one or maybe two pads that are still disconnected from the bottom side. Yeah, so I need to put a wire in. I think we could already give it a go, but not completely sure. So just fix this first. There. Stay up. Okay. I think just one more. There's one way too close to another bed, so I really have to make sure that it's not creating any problem here. I can move it just a bit. There's really not much space, so I most probably will use a bit of extra glue to make sure it won't come off anytime soon. And there is a problem with one of the pins that I cannot put anything into. work or will it not? Really hard to tell. So I will add a wire, one more wire here. That should do the trick. Let me clean up with a little bit of IPA. Yeah, but some boards do not take up this amount of time, but some do. So hence the price for a refurbished board or for the service to refurbish yours is what it says on the website. It's really a lot of work, as you can see. And it's not the biggest deal because partially I do this because I like it, but also I want to make it a living, obviously. So shouldn't take too much time. Alright, most is looking good. Is there any detached wire there, or what is it? No, it's something on, so it's connected. I will measure in a second if everything is connected properly. And I'm doing some last checks to see if there's no short anywhere. I don't think so. Okay, that's fine. There's only one place that I'm doubting if it will make proper contact, so let me check if I can add a wire to that hole. I think I should. So the hole's open now, so that's good. Oh, don't drop the board. So it's the third hole from that side on the left chip. Let me check. It's really hard to tell if that will make proper contact. I think it will, so I think we're good, at least for testing now. We can see if we solve the problem. We created a new one, but if we solve the first problem, we can put new sockets in here later on. So let's get to the other side and see if this board will now test lower RAM properly, at least. Yeah, that looks a lot better, don't you think? Let me grab two 16-pin sockets here. Mark ruins stuff. No, I will never ruin my workplace, and I really have to do with Mark. Come on. Oh. All right. Yeah, no, there are two chips missing, 20 and 21. It will tell me that those two chips need replacement. Oh, it doesn't. I should power it up because there's only 7805 regulator on the board, which is heating up. We'll fix that. So last work on this board. What is everybody telling you? Oh, you could. Oh, you, Mark. You're. Now I get it. Okay, Mark fixes stuff. No, Mark ruins stuff. Well, you can always give it a try, Mark. Everyone can learn. It's not the hardest. I've never visited your place, Mark. I visited Renee. I actually haven't never damaged a ULA. Tracks on the ULA socket underneath the ULA socket, so maybe that gives some trust in that. All right. Now let's see if we can get upper arm working as well, and then we learned a lot again. First, the question is if these sockets will get in place here, because there's not much space where I put in wires. Okay, there's one problem there. Let me do another check, final check before I put in the sockets. Because if I'm doing it wrong now, then it will be a lot more work to get it working or get the sockets out correctly. Okay, there's one hole that I need to get some solder out first. Nope, it's not enough. What is going on there? I think now it should be open. Yeah, I think so. Oh, I don't want to put in sockets, by the way. I just want to put in new chips. Sorry. Before I do anything else, let's just put in chips. These are 3532s, 4532s. I got two left here. They're just slightly different, but I think I can use them. This one here, and this one. And the good thing is that for instead of using sockets, you can solder the top of the board as well this way. So that's a good thing. All right. So all the chips I got here are tested. And the question is if I can get them inside the holes with the wires. So one goes in properly. Now the other one as well. The hole's not open. Dang. Might be the super glue. Yeah, this is glue. So I need something to get through and through the hole here. Without creating new problems. So the good thing doing it this way without sockets also is that you won't be able to see that there has been damage underneath. But obviously, when there needs to be repair in the future, it will get harder. Darren, hopefully this is it. You can still see between the two chips that there is some damage, but when it's cleaned up, you can barely see it. Alright, let's hope this is all go. Oh, I'm forgetting something important here. Fortunately, I only soldered 2 pins on each, one on each, which is these are the wrong chips. So these are 4532s, but there are 2 types because Sinclair bought batches of faulty chips, and you need matching numbers, otherwise it won't work. So if I don't have these, and I think I have it just in another place, we'll check it in a second. I can also use the 4164 chips, which have 2 working banks and don't mind which one is used. So these 2 can go back here, and I need the other ones, so with the 4 in the end, and I don't seem to have them. Don't think so. Nope. So I then will use the 4164 chips. Here's one. I don't have two which are exactly the same, which is a pity, but it's not the biggest deal. I don't like it. I want exactly the same ones. Let me check. I'm sure I don't have any other types. Maybe I have them in another board. Where's my other reference board? It's here. Chips are in here. Nope, also modern ones. And it's really hard to reach the other stack of boards, but I will give it a go, because there might be one that I can just pull out here. Let's see if there is a socketed board with upper ramp chip socketed, which are the correct type. That would be nice if I can find those. No luck yet. These are Oki ones, not TI ones, unfortunately. So I've got a board with the correct chips here, but it's really pity to get them out from this board. But I think we're in luck. I found one. And this board has 3 chips on sockets from the same type. And these are a lot nicer because they're also looking the identical. So it's perfect. Right. That's one. Ah, this is the wrong one. Dang. Sorry. This is not the one that I just pulled from the other board. This one is. And this one is. Okay. So that should be a solution. Let me give it a try. And I think I want to do some measurements if all pins are okay and not shorted or something, but we can also just give it a try. There's not much that could go wrong if there is a short somewhere with these pins. So, and I'll clean it up later because it's not looking very nice from top. At least the board should work. That's the most important, obviously. Okay. I will give it one close inspection with the magnifier. That looks quite nice. Yeah, I think this will work. Right. What do you think, guys? All right. Okay, let's give it a try. Let's see, will this board work completely now? Please, let everything be green. Yeah, I know, there's still no ROM chip in. I know. Oh no, there's still RAM failure. Dang. And it's not clear what it could be, and I really hope it's not the PCF chip. Could it be the PCF chip? Also get a glitch on the screen now, so could it be the PCF chip then? So we had two bad chips. Could it be this another chip defective, or could it be the PCF chip? And that's really hard to tell. Let's first make sure that the repair that I did is working properly now. And yeah, let's do some measurements first. Right. Oh. Okay, so let's see. Let's clean up a bit here. Oh. Okay. Now we have some space. And we can test if the lines are going to all the pins correctly. So it's about the same, I think. Yeah, everything should be connected except for pin 2 and 14. Yeah, I think so. Right. So far so good. Okay, I can't find anything wrong so far. So if there is a short, I should be able to find it another way. And of course I can check if the that's odd. Pins 1 and 14, what are those? Let me check. Oh yeah, they're connected both to ground, so that's good. Okay, I got a connection node. I think that's alright as well. That's pin 7. Pin 7 is A2. No, that shouldn't be connected to ground. God. I got a short between 2, 3, 4, 5, 6, 7. Pin 7 and ground. And that should not happen here. That's an address line. So I got a shorted address line at this moment. Which sucks. Alright. Let me see if I can easily find it by using my brain. The question is there an obvious place where they could touch each other? Because why does it say pin 28? It should say pin 18. No, there's no pin 28. What the hell is that? 5 volt on pin, I don't know, pin 8. Okay, it should pin 8. Okay, this is pin 8. It's 5 volts. Yeah, this is not touching. No. Right. Where could A6 be pulled to ground? Well, it could happen inside the PCF 1306. So I really doubt if this chip is working properly. So we have to get it out and see if the short is gone then. There's no other way of doing this, I think, because I don't think there is a place where A6 could touch ground below the 2 chips that we replaced. No, it can't be. So what could it be then? So I suspect the PCF chip, especially because I really don't know. That's what I suspect. So we have to get it out. That's the only thing I can say about that. So let's do that. So this is a really tough board, as you can see. We will get there, but it will take a lot of time. Maybe up to 2 hours this time. So I'm not sure, but I think it's the chip, because I don't think there's a place where A6 could touch ground underneath the chips we replaced, as I said before. Hence I suspect this chip is damaged, and that could be the cause, because there were some more dead chips on this board. So maybe someone pulled an interface from the machine when the power was on. That could cause these kinds of damages. That's really a tough one. At least this looked simple. So far. Nope, not completely. Oh, there's one pin stuck here. Okay. Let's see, a couple that are not completely detached. Is better. Yeah. Oh. Alright. Let's see if we didn't do any damage to these tracks, and they all look perfect. So I think this went perfectly fine. Now the question, of course, is there a problem still remaining on A6? And there is. So it wasn't the chip. There must be something with the repairs we've done ourselves then, unfortunately. And that's really a pity, because I don't know what it could be. It could still be one of the upper RAM chips, which is my guess right now. I think it's one of the chips. Because I don't want to get them out, all of them. So what the problem is, the ground is only connected to pin 1 and 16, sorry, and we're talking about signal A6 here on pin 7. Let me check once again. Yeah. They say A6 is A2, but that doesn't matter. Pin 7, A2. So the question is, where could ground touch that pin, the signal on pin 7 of the RAM chips? I know it can be wrong, because these are address lines, 8 address lines connected to these ZX8401, sorry. So this chip here, which we just pulled off. So it cannot be the ROM. It's an address line only connected to that address, to that control chip here. And I don't know if there's any way of, the pads weren't even touched, so I don't think so. Is ground connected to another pin maybe? No, I don't think so. Let me check, but I don't think so. Ground is only on pin 1 and 14. So here. There. No, so I think one of the RAM chips is still failing, and it's really hard to find the correct chip without removing them or doing it the other way. Which is okay, I have a couple of ideas. I could cut, this is just a wire that I have to be removed. I could cut pin 7 of the remaining RAM chips that we didn't yet touched, but I don't like it because you can solder it back obviously, but it's not nice to see. What I could also do is yeah, so the lower 4 chips here, the signal A2 from pin 7 arrives from this track on the board. So what I want to do is cut this track, which is easily repairable, and see if the problem still remains, and see in which side of those 4 chips, which of those 4 chips have the short. That's the best thing I can do. So the question is, which of these sides carry the short, have the short on it? So we can at least see if it's the upper 4 or the lower 4. Alright, so we cut them. That means there's no continuity between these and these, yeah. Now the question is the short here or here? And you heard it, it's in one of the 4 lower chips here. So the short is somewhere in those 4 chips, most probably, or there should be a short on the board, but it's the same as it with the top 4. There's no ground getting close to pin 7. I'm checking again and again, but I don't see any reason for that. So the only question remaining is, which of the 4 is causing the short? Which of these 4? That's the only thing. But I know already that it's not this chip here. I think I will put a socket in the board for later. Can't do any harm. Alright, let's do this first, and let's then check which of the 4 chips is causing this problem. I think I just need to get them out one by one. I think that's the best. Oh wait, I could just, it's really hard. I could cut the legs and see which it is. I think that would be the best, because we know the tracks of this board are fragile, especially around those upper RAM chips, and I don't want to do any more damage to the board than which has already been done. So what I do want to do now is just cut pin 7 of every one of those chips one by one and see if the short will disappear. It will disappear. That must be. So which one of these is causing the short? Let's name this 1, 2, 3, and 4. Which should I try first? 1, 2, 3, or 4? You tell me. We'll do it that way. It's a gamble. 1, 2, 3, 4. Which chip will we cut pin 7 off first? You tell me. 1, 2, 3, or 4? 1, 2, 3, or 4? I got a 4. Can you test which one got warm? I couldn't feel that any of them got warm, but I can try again, of course. But I don't think that's the way of finding the one that is causing this problem. Why does this chip not want to get in? It wants to get in now, and in the meantime I will remove the or replace the voltage regulator. Alright. 4, 2, 1. I get 2 4s and 2 2s. I think it's good to start with 4 then. But it's a good idea to feel if any of them are getting warmer. But I just felt and it didn't feel that anyone was getting warmer than the others. But I could try again. Alright. Let's feel. Let's feel. And we don't need this soldering iron for cutting legs of chips, so let's do this way. We need this one, of course. Check if the short is gone. Alright. Use the dice. Well, you are my dice, guys. Right, let's see. It won't boot up now, which is not good. Okay, I just put back the PCF chip. Let me check if there's a short in between one of those pins here. It is kind of dirty, so maybe I should do some IPA first. Just a second, guys. Alright. And I put in a ROM, so maybe that's a problem. I don't know. Can pull out the ROM again. Just a second. Let's not make it any worse. We'll pull out the ROM just to make sure it's not causing troubles. Oh, of course, the ROM might have been a problem because I need to do another modification on this board to get this type of ROM working. So most probably it's now booting up again. Let's see. Okay. So I haven't cut anything. What would I wanted to do? I think I just wanted to cut first. Okay, it's working anyway. For now, this is working. The problem is not gone. It can be gone. There's no ROM, I know. Oh. I want to see if the short is gone. That's the only thing I want to see. But let's do another quick test. It will still give the same result. I can't imagine it otherwise. And usually if one of the chips is failing, it will just pinpoint the chip that is causing the problem. But because there's a short on the address line A2, the software can make out which of the chips is causing the problem. So we cut A2 to the lower 4 chips. So because of that, we wanted to know which one got warm. That's what we wanted to try, didn't we? That's true. I can't feel any of these warm up. Or is one getting warmer than the other? It's really hard to tell. That's what we wanted to find out, but they do feel like getting warmer, but it's really hard to tell. It's really hard to tell. Let me get my digital thermometer. Just a second. Where is it? It's not here. Oh, maybe it's in the electrical tools drawer. Yeah, it is. Okay. Let me check if I can find by measuring which one gets the warmest. Warmest. Oh, the right one is 27 degrees and the other one is 23 degrees. So do we have a winner here? Yeah, I think it's the rightest one. So let's see if that helped. Did it help? So I'm going to cut the pin now and see if the short is gone. Too thick. Okay, so I cut the track. Is the short gone now? I'm not sure. I'm still not sure. No, it's not gone. It's still here, as you can hear. So it's not that chip, I guess. So we'll just go and cut the other ones and see if we can find it. Still not. I don't like cutting these legs, but this is not disconnected yet. No, it is. Yeah, no. That's odd. It is disconnected, is it? Or is it not? It is disconnected. Why is it still failing? Are two chips failing? This chip gives me short. This is not. This is not. I guess two chips are still failing. Dang. Can you believe that? Yeah. Two chips. Two chips are still failing. Wow. What a terrible board this is. Let me check if I can find another one. This one here. Okay, let me first mark these chips here because it's really terrible. So two chips, two chips are still failing. Number one and number two. Let me check again if I marked the correct ones. Man, this is terrible. This board is just terrible. So many dead parts. Yeah. And the other ones seem to be okay for now. We'll find out later. Okay, we'll get there in the end. We'll solder back these two first in a minute, but I do have to remove more chips, which I don't like at all, but we have to. Yeah. So I got one working here, and I hope to be able to find another board that has chips that I can just pull. Otherwise I might desolder one of those, but I don't like doing that. Not yet. One more box to go. These are all issue 2 boards, but could be one in here, of course. We got a nice board here, but they're all type 3, not type 4, which is a pity. Really need the other one. What else do we have? Okies, plenty of Okies. And I got a board with, again, all 3s, not 4s. And these are Okies as well. Oh no. Let me check again. Okie, lots of Okie. Okies, socketed Okies. Nope, unfortunately not. So I have to do it with those, and maybe I will remove one. This is a kind of a pity, but we'll get there. Yeah, maybe you're right. Just cut the legs. I think that's a better way. I think you're right. We know now that these two chips are malfunctioning, so why not cut them and remove it that way? That's a good idea. Okay, that's one side. But I still have to find one from another board. Oh. Sorry. Let me check one sec if I get messages or so. Thank you, Uwe. Who just ordered some replacement RAM chips. And I got some Discord messages. Let me check, one sec. It's not downloading the picture, I don't know why. No idea. Alright, we'll see about it later. Okay, now the other chip. So this is again a terrible stream with all the work. Taking 2 hours for one board only. It's a pity. But we'll get it working in the end. Alright. Legless chip. Yeah, I think so, Uwe. It should work just fine. The speeds are about the same, so that shouldn't matter. Yeah, I hope these are the only 2 remaining chips that need to be replaced, and I will try to get one from another board. Oh, there's a 4 on here as well, so we'll just grab this one. I just don't know if it works, so I should test it before in a reference board. And I can use this one. We'll test this chip in a second. This is my board where I pull the other chips from and put it here. Do a quick test on this one for the chip. Oh, it's a free board now. I can't test it on this one. Just a second. There's another type. I need a reference board. Where did I leave that? Oh, here. It's also wired to 3, so that won't work as well. Man, I don't want to take the risk and solder it in without testing, so that's not something I'd like to do. What I will do is to solder one from the other board that I just got. Anyway, first let's solder back these 2 pins here. And we have to remember that we need to repair the track on the back of the board. Let's get these pins out. Alright. With the pliers. It's a good idea. Sometimes I do this, but only if you know for sure that the parts are not working. So this is another way of removing a chip. So this board has been damaged quite significantly. I guess because someone pulled out in its face, because the 7805 5-volt regulator was still working, and the other reason that this damage could occur on a board is when the someone used the wrong power supply, for example. But then most of the time the 7805 is not working anymore as well. And on this board it was still the original one. So that's why I think it must have another external cause. So I think the previous owner has tried to repair the board himself, first by removing all lower RAM chips and putting new ones in, because I think these are from eBay or something. And he didn't succeed because there were still some troubles left. At least 2 RAM chips that we already replaced, and now we are still coping with 2 other upper RAM chips that are failing as well. And I hope it will stay like that, because so this board really needs some time to test properly. So we'll if it's done and got new capacitors, I will keep it on for an hour or 2 and see if it's fully functional and stable, because there is a chance that the other lower RAM chips, or sorry, upper RAM chips will fail as well soon. It's not certain, but it could be. It could just be the way that the interface has been detached, and there's nothing wrong with the other RAM chips, of course. So. Almost done with getting all the pins out. Not that easy. Alright, one more pin to go here. Getting a real mess on the table, but it's something for later. Now we only need to get the solder out of the pads, and we're good to go. that was kind of a lot of work. Okay. That's okay. Oh, do I see some minor damage there? It's no big deal. Oh, it is a big deal because I see a short. Let's see if we can move to the side. Nope. Don't know how that happened, but it's good. Yep. Alright, so I should be able to put new chips in now without any problem. Before doing that, I will fix that wire that we removed. Or cut. I need to scrape a bit. Right. Got only a tiny wire in it and we're done. Put 2 new chips in. Okay, that's fixed. So, I got one working chip here. It's a 4, so it's a good one. Correct one. Alright, and then I will get one from the other board, which I put somewhere. Where did I put it? I think here. Yeah, I want to get that chip out as well, and it's not a big deal on this board because there are 3 sockets already in, so probably I will socket the rest of these chips later on anyway, so for this board it doesn't matter, this is another board. We'll do that. I want to get the same chips. Clocking up again. We should empty it soon. Yeah, it's really filled up. All the usage. One more pin. Not enough, but almost. This must do it. Right, no damage, so that's for another time, that board. Right, so let's put this one in, and I really hope that's all, and this board is going to run again. We'll see it in a couple of seconds. I will give it a clean in a second as well, because there's still a lot of garbage. Alright. I really hope this was all it needed. Hey Franco! Well, I'm working on this board for over 1.5 hours, maybe later, longer already. So it wasn't the easiest. To recap what we did, we started by trying it with the die card and found out that did we need to replace the we need to replace the voltage regulators. That was the first thing we found out. Then we found out that 2 upper RAM chips were giving errors, but what I did first is, because these were socketed already, I replaced these 2 with the lower 2, and the same problem still occurred. So these 2 data lines gave an error. So I removed the sockets because I thought there might have been track damage on the board, but there wasn't any. So I thought, what could it be? What else could it be then? I got to the schematic and I found that these 2 chips were causing issues. So I removed them and got a lot of track damage, because that part of the board seemed to be very fragile. But still there was a problem when I replaced those 2, so we got a clean picture and no more lower RAM faults. But I didn't know what could cause the upper RAM errors that we still got. So I thought maybe the PCF 1306 chip was failing, but it wasn't. And we found out that there was a short between address line 2 and ground. That's the reason I suspected that PCF 1306 chip, but it wasn't the cause. It was a short in one of the RAM chips. And to find out which of the RAM chips was actually failing, I thought let's cut the pin where A2 is connected to, and I found that these 2 chips were both failing still as well. So we replaced 4 upper RAM chips in total without socket. I like that a bit more. I just shouldn't write with paint pen anymore on these chips, because it's really hard to get the OK label off. But with an eraser that will probably be removed in the end, so that we'll do that later. I'm still trying to get away all the flux remainders and prove that I did work on this board and these chips a lot, so it should look as good as new if this is done. It looks already a lot better, so alright. Oh, and the Z80 was dead as well, so we replaced that in the meantime. So this board has gotten a lot of repairs already. Now the question is, did we get out all the problems now? I think we did. I think we did. So I bet this is going to not give any more problems with the die card, except for a ROM, which I will check later, solve later. It's just a matter of rewiring some stuff, because I'm using an EEPROM. There was no ROM on this board. So I use a lot of IPA. You can see how yellow the tissue is getting. Oh, and the clock circuit was not working, so we replaced a transistor. Oh man, we did a lot on this board. But I'm not sure if it was a transistor or it was only the Z80 in the end, so it's no big deal. Transistor is easy to replace. Most of the yellow is gone now. It's also the solder mask from the bottom of the board a bit, but I don't like seeing flux remainders between or on solder pins. Looks a lot better now. Alright. Alright. Don't want to be any alcohol remaining when I power on the board again. And it's looking very nice now. There's almost no proof that there has been soldering done on the bottom of the board from what you can see here. All right. I don't have any eraser at this side, so I will get that later. There weren't any UDA chips on this board, so I grabbed one. Already succulent, as you can see. Alright, for now this is good enough. We want to see if the board is working again. And I will add some more IPA or clean it with some more IPA later. Alright, I am curious. What do you think, guys? I think we got rid of all the faults. So it should work. And we have to wait until the wrong error moves away, so just have to see what it does. So this is normal because there's no ROM chip on this board at this moment, no problem. Just have to wait a couple of seconds. I could grab a keyboard, but I'm lazy. Oh, still an upper arm fault. Oh my god. We did not measure if the short is gone completely now, so that's one thing we can do. And we get exactly the same error still, so I wonder. Did we get rid of that error? We did get rid of the short, so there's no more short here. But we still have an error. Let me check if everything's connected. Yeah, so it's all connected now. that's not an issue here. But we still have an error. So yeah, what could it be then? This is just really painful. There's no short anywhere else. I have absolutely no idea. So I guess we need to remove more chips and find another one that's defective or so. This is really a tough board. I wonder what it could be. What chip could it be now? What could it be? I have no idea. There could still be an error with the PCF chip because we don't know if it's working properly. So what I could try is if to find if I got one spare chip somewhere. I'm not sure about that, but let's find out. That is an interface 1 ULA chip. We don't need that. Do I have a PCF 1306 or ZX8402 or 8401? What is it? Somewhere still. I don't think I got one on my test boards. I don't think I have a replacement or a similar chip here. I'm looking, but I don't think so. Not at this moment, so I will I will need to check my stack of boards once again. Yeah, what has happened to the poor thing? Again, what I think is someone just pulled a interface from the board and killed it completely. Okay, this is just because there's no ROM on the board, it's no big deal. I still suspect the RAM chips here. I don't think it's completely well because it was warmer than the other ones. But what I'm going to do is think of what I'm going to do. I don't know. There's so many options. I wish I had a spare chip, but I don't think so. I'm not sure, at least. Let me check. Where is my stick of issue 6 board? Is there another issue 6 board here? Maybe with a socketed PCF chip already. Yeah! Haha! Yeah, we got one. Woo! Let's see. Oh, I'm covered in dust. That was not clean. But we got a spare chip. I have no idea if that's working, but we can see if it does anything differently. Ah. All right. Okay. Let's see. Let's see about that. Yeah, I could. I did reconnect A2, but I could just cut out the other RAM chips. If it was the power supply, then I guess the 7805 chip, voltage regulator would have died as well, which is still working. So I don't think it's a power related problem. Let's see what this replacement chip does. If it's exactly the same, then I really should remove the other RAM chips, which is a pity because I would have socketed them, obviously. So we still have an error. Let's see if it's exactly the same fault. I think so. Huh? Failures found in bit 0. That's different. That's different. I will get a keyboard and we'll try again. So I'm not sure if this is caused by the chip that we just put in, or if this chip is working and now it indicates that one of the upper RAM chip is failing. It is kind of a strange problem. Oh, maybe it's because we didn't select the ROM. I did select it's a 48K now, so if it's bit 0, we know exactly which RAM chip is failing, and it doesn't say. Failure is found in bits 0. Bit 0. Bit 0 is simply IC 16, I guess, or 15. 15 is it? Yeah, it's 15. So that's the chip that felt warmer than the other ones. Let me check if it's still warmer. So the board is 23, and yeah, it's indeed warmer. So, okay. We will do one final swap of a RAM chip, and just to not forget which chips we already did, I will put a pencil dot on it. So I replaced this one and this one and this one and this one, and now we are going to replace the one more RAM chip and see if that is indeed failing. But it is kind of a odd error, and also if the PC chip also is damaged, then of course that would be terrible because those chips are extremely rare. Maybe I should, I could give it a go sourcing it at my suppliers. Maybe I will write it down for later. Just a second, because I have a list of rare parts. So this is PCF 1306P or ZX8401, one of those two. I want to give it a try later. Anyway, oh, that's odd. Die cut is dead. I wonder what could be wrong with it then. Could you try to set a jumper to boot up the Spectrum ROM instead of the diagram to see if the hardware of the interface is still working? And of course you can get the image, but that's no problem. Let me just start with cutting all these pins from this chip, which I think is still one that is failing, and I hope it's the last one. You know, we don't know that, but let's hope. But I'm afraid that the PCF chip is also failing, but we'll see. I'm getting hungry. I have to wait until it's heated up. I still do like doing these repairs, but this is just one terrible board. You get it from time to time. And the problem is, if you do it live, then you really need to fix it, you know. Otherwise I could just replace it. But now you are looking, so sometimes I discard a board, get all the parts off, not with the soldering iron, but with a little bit more heat, let's call it that. And it's not a big deal, because there are a lot of parts that aren't being made anymore, like the toroid, the speaker, RAM chips. Yeah, well, you can get black topped ones if you want. So ULA chip, for example. So it's not that terrible, I think, to sometimes discard a board for the parts as a donor. But if we can fix it, we should. And the question is, what is too much time spending on one board? When does it become too much? I could say that for me it's too much when it takes more than an hour, but if you already spend an hour on the board, then you know that it can be that much more to finish it completely, you know. If you're on, if you're finding all the faults. So it's hard to say, well, when you spend an hour already, it's not useful to continue, because maybe it's fixed in 5 more minutes. You don't know that. Like this board. Sometimes I see that there are many parts damaged, and then I think, well, we'll discard this board. But not when I spent so much time already fixing loads of parts. Okay, now we need a donor chip. Okay. Okay, so yeah, so I got this board, but I don't want to use that because I don't know if those chips are working. Where is my other donor board then? Did I put it back in the crate? I think so. So I just have to find it again. Yeah, I must have put it back. Alright. I thought I put it aside, but I don't see it anywhere. So I guess I put it back. Anyway, let's find it then. Is it this one? No, not this one. Where did I put that board? I don't know. Alright, so what I want is one of those chips here, and I'm going to do it by hand. I also don't know if these chips work, so it really doesn't matter that much. I could test this one, I think, or maybe not. No, I don't know. Let's just get it out. It's hard to tell. Not the wisest thing to do. Anyway. Almost. All right. Yeah, that's what I was looking for. So, okay, well, I just assume that this chip is working, so let's put it in. Alright, and that one easy. Soldering it in is easy. Alright. That seems to be fine. Although I do see another problem there, so let's check it out. Oh, it was solid on there, now I get it. Okay, so tiny problem, but I don't think that influences the board during testing, but okay, I didn't check that properly, which is not good, but okay, it's solid on correctly now. Let me check, double check. Okay, I don't think that's a problem. Alright, well, I'm hoping that we found the last problem from this board now. We still am curious if the PCF chip was failing or not. We'll find it out if this board is now working. Let me check. Hey, Imre. 2 months, yeah. 8 to 10 boards a day. Well, yeah, but I guess those were more complex than ZX Spectrums. I hope so, for them. Alright, let's see. Let's attach the keyboard so we can skip the ROM check. Still a failure. I wonder what. Bit 5. Dang it. Oh god. But that is a chip that we already replaced. I don't like that. Maybe no. Come on. Okay, let's swap back the PCF chip first and see if we get the same error now. If not, then this PCF chip also has a fault, but I actually don't know if that RAM chip was working, so that could be a cause. Let me see, do we get the same bit 5 error? No. So it seems that this PCF chip has more problems than the other one, which is interesting. What we also can see is that we did indeed solve a problem with the RAM chip, because we do not get the bit 0 error message, but we get a bit 5 error message, which is this chip here. And the question then is that chip still failing or not? I will check the temperature. So these are all 24 degrees. Yeah, the replacement also is only 24 degrees now. And we get 25, we get 25, 25. No, nothing special here. So it's heating up slowly, but I can't find it in temperature. So my best guess is that this chip is also failing now, which is, oh man, kind of a hard job, because I don't know if I can get it out without damaging the tracks again, which we already solved. I'm going to check once more if there's no obvious problem with the tracks there. Doesn't seem so. So no, I can only guess that the chip is still failing. That's what you get if you cannot test it properly, because you don't have a board with the same chips on it. Yeah, well, of course I can cut these legs as well, but again there's some damage on the tracks underneath, so I have to be very careful. And I would really like to know if I get a chip that is working, or just put in a 4164 chip instead, which might be safer. Throw it out of the window. No, 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 no. Okay, I think it's time to put that one 4164 chip that we have in. This is the last thing I will do to this board on the stream tonight, and I will get to dinner then. But I want to do this and see if we can still fix it. All right. This is the replacement chip. So this one still seems to be faulty, 567, yeah. Want to make sure. And I guess because it has not detected the ROM on its own, it doesn't tell you which chip number it is. But it must be this one. Let's hope so. I really wouldn't have guessed that there are so many problems with this board. Really pity. You just never know before you start working on a board what is wrong with it. But you see, we're getting closer to finishing this repair. One step at a time. It's very slow with this board. Okay. That went quickly. Right. Okay, one hole is closed up again. Why? Maybe it's glue. Could be glue. Yeah, I think it's glue. All right. Let's put in this working tested chip. Okay, I will do some quick measurements on all the signals if they're connected properly. Right. I just see one detail that I'm not entirely sure if it's good, so I'm going to use some solder from the top here. Yes. Right. This is looking fine, so I hope I have good hopes. I hope this will work now. Right. I bet it works. I bet it works. I say it will work. Well, a lot of damage on this board, indeed. Look, no red. No red yet. We won! Our perseverance. Yeah! Okay. Okay. Can I be dismissed now? I will check the other chip, but I'm really afraid this one is damaged. I already don't hope so because they're so rare. Dang it, you board. Nah, the PCF chip is dead. Dang. Ah! I have to put a cross on it. Oh, it's really too bad. So we had loads of problems on this board. But fortunately with this chip, it's still working. Too bad for the chip. Too bad, you precious PCF 1306P. You toast track chip. Gotten into a Spectrum 48K board. You didn't deserve this, but anyway. RAM chips are common to fail, but right. At least the rest of the board is working. And I'm really glad we fixed it because it would have been a waste of time. Oh man. I'm hungry. Alright, I will fix the rest later of this board. So we need to replace the capacitors, obviously. ROM chip. Remove the ULA socket. So we're not done yet. But at least it's working. So I'm happy it won't reset to 48K basic because there's no 48K basic ROM in. And the reason for that is, you could think, why did we not put a 48K ROM inside the die-cut ROM chip, because there's plenty of space in there. Or the same with, for example, any diffMC interface, or this one here, for example. And the reason is very simple. There are still intellectual property rights owned by Comcast at this moment for the original 48K ROM chip. So it shouldn't be allowed to add the 48K ROM image into, for example, the ROM chip of the, which is this one now, by the way, ROM chip of a diffMC interface. So what it actually does is, when it boots up, it copies the ROM chip contents from the ZX Spectrum itself to its SRAM chip, and then pages out the ROM chip completely, so it can switch a lot faster between ROM banks here, and here. Which solved it, but this doesn't harm intellectual property, so that's the reason that it's done that way. I think the same with the divided interface. So for example, if someone offers programmed ROMs that he programmed himself on eBay or something like that, it's not allowed to sell that on eBay or somewhere else. I cannot offer those chips but of course sometimes I use them for my own boards, program chips, and I'm not allowed to say that loud, I think, but if you do it yourself, no one will know and no one will bother. And of course, when you have a defective ROM chip, it's no problem at all to replace it with a working one. So that's what I want to say about APROMs, but that's the reason why there's no ROM image 40K basic ROM or something inside here. There are some Easter eggs inside the ROM, but I won't tell you about that. You have to find it yourself. Anyway, enough for now. I'm happy that we solved 2 boards at least. I wanted to do loads more, but we couldn't. So the next one is one that is remaining here. Also 6A. I only needed one, but I like to just fix them all. One reason is that I have boards on the shelf completely refurbished. So you can order one at zxspectrum.shop if you want to, and select which board version you want. It's that modern. You can select which board version you like. If you don't mind, you can just say I don't mind, or you can say at least I want it to be issue 3 or higher, or issue 4 or higher. So you can do that. Anyway, get over to zxspectrum.shop to get something cool for your ZX Spectrum, or sponsor me at the same time if you want to. But I also like you to have spend time with me here in the stream and do a lot of chats. I like that a lot. Cross off half the components on the bill of materials. Yeah, indeed. Well, that's what I wanted to say for now. I'm happy that we did it, and I will continue tomorrow. I wish I could do more today, but tomorrow I will continue. I've got some family stuff to do tonight. I will be here back, and I will continue with repairs throughout the week. There's not much reason not to, and also we'll do live assembly of the ZX HD, as I said in the beginning of the stream. Anyway, for now, this was